Let's take a look at slag inclusion. This test specimen I have, this weld, has slag inclusion. And slag is a defect when a stick weld is used, shielded metal arc weld. It will leave like a protective scab material, non-metallic material, on a weld. In between passes, the welder has to clean it out. If they don't, then it can entrap some of this non-metallic material in there. It's called slag. So this weld that I have today is the base metal is 0.625 inches thick, and right about in the center line of that weld we have some slag. So I'm using my Epic 1000, and I am using a 60-degree wedge on a 4 megahertz transducer, 10 millimeter diameter transducer, and I calibrated on an IIW block, and my reference gain is set at 63.8 dB. I used the 0.6 deep side drilled hole on my IIW block as my reference. And what I'm doing right now is I moved my gain up. I increased the gain to 12 dB hot. I increased it by 12 dB just to give us some good signals. And I set the range up so that I'm at 2 full leg lengths, sound path, 2 legs, the full V skip. About midway is my first leg, and then the end of my second leg. So one thing I want to show you real quick, this is typical geometry. Looking at this weld, this is a good area of the weld, defect free, right there about mid screen. That is the very bottom of the weld. That's my root signal. That's geometry. As I pull back, we'll see that signal jump up. It is my toe of the weld, geometry. And right here, I can maybe finger dampen it. You can see it a little bit. But those are normal geometry signals that you'll see. Now, as I scan over right here, right in the middle of this weld, that is a slag inclusion. The slag inclusion is a volumetric signal, and you can kind of see some of these, some of the volume of that. But here it is. Let me move parallel to the weld. Right here is our defect, our slag inclusion. Now as I move parallel, we'll see it go away. There, it's gone. We're coming back into it. That's kind of a telltale slag inclusion. And we'll see the other end of it where it goes away. And I'm kind of sticking a little bit here, but here we go. See that? That's kind of a telltale looking slag inclusion. And then it goes away. The other thing about slag is that we can see it from both sides of the weld. I come over on the other side. Again, there's my typical geometry. Root, pull back, and see my my far side toe. Now let's find it, and here we go. Right there is rotate this guy and kind of look at that and see that. It's kind of like a little saddle here. That's kind of typical porosity. Pardon me, slag inclusion. Now I'm running 12 dB hot. Let me pull this down to our reference dB, where I use the side drilled hole, and my reference that I used for the 0.6 deep side drilled hole. And let's look at, see, my geometry still shows up good, my root, and then the toe of my weld. But see, this this slag inclusion is fairly low amplitude. Let me come over on this side, get my hand out of the way. You can see there's not a whole lot. It's very low amplitude. I'm only about 20% full screen height. And when I calibrated and set my reference level for the side drilled hole, I set it at 80% full screen height. So you see it's fairly low amplitude. So that's another reason why you want to run, when you're scanning, depending on your code, like 6 dB hot. Right now there's adding 6 dB to my reference level, and that's pretty good. See, that shows up pretty nice. But the reason you want to run a little bit hot, and there's a good representation of what slag inclusion looks like. But you always want to run a little bit hot, depending on your code, because then it will alert you to small indications in the weld, and then you can go back to your reference level to analyze them to see if they're significant or not. But this is a typical signal that you get from slag inclusion.